Hi, I show you the NOC implementation of ACOnet, and Peter asked me to make a short flash presentation about between, I guess, 5 and 10 minutes. So I'm a little bit surprised about the first ones, and mine will be much shorter, I guess. There are some things I want to mention, and some things where I just included some links because I've described our monitoring and statistics tool already very extensively during the last RIPE meeting. And since this session was recorded and also the slides are online, you find links about this in the presentation. It's Control L. First of all, the team I'm working for is, we are employees of Vienna University. So ACOnet is not a real legal entity. It's a service provided by Vienna University. And we are not only responsible for the National Research Network, but we also operate the local internet exchange in Vienna. So the stuff that is operating these both services of Vienna University is the same, and also the tools we're using are designed to fulfill both purposes we are responsible for. Now to the academic network, you see here, didn't you have a laser pointer somewhere? No problem. I can take the mouse, I guess. This is the topology of ACOnet, and you see here within Vienna we do have perhaps the mouse has the advantage that remote participants can also see it. So I'll take the mouse here. Within Vienna we do have 2 POPs. Both of them are interconnected with two independent pairs of dark fiber. As you know, we have River Danube in Vienna, and we selected 2 different bridges to cross this river. And then we have exclusively for us operated infrastructure from Telekom Austria to have these 5 rings, always starting from one point in Vienna to one POP in the remote city, connected to the second POP and back on the other POP in Vienna. We are able to use 40 times 10 gig on these links, and so far we only use one lambda of 10 gigabit on these links. The part of Niederösterreich here is a little bit slower. It's only 1 gigabit per second, and those POPs and those small POPs here are only connected with a gigabit, multiplex gigabit over 10 gigabit lines. So we do not have active equipment here in Dornbirn, Leoben, and Eisenstadt. There are only several gigabit links that terminate directly at the members. The staff I work for is only located here in Vienna, but all of these POPs here all over Austria are located at other universities. So normally we have the idea of having the POPs at the local biggest member that is connected to ACOnet, and they get some kind of responsibility in case of troubleshooting. So all of the operational and planned things, scheduled things are operated by us. But if wrong, for example, these people there have the enable password indicating repair. This normally works quite good, as the biggest connected member on a POP has the greatest interest to having network. Services we provide is normal internet access, and in the last time it was more and more interest of having kind of private infrastructure. So members do want to have transparent layer 2 connections or layer 3 connections. And I just wrote clouds on the slide because cloud is now in everyone's mouth. We have some constructions where they want customers want to have kind of multi-point connections, so we built and separated infrastructure for them. The monitoring part is our most advanced. We have improved the performance of it dramatically during the last year, and I've also seen it on some of the slides before. We use Isinga for monitoring. Isinga is a spin-off of Nagios, and I've seen there's been some activity regarding plugins. So Isinga is fully compatible, backwards compatible with Nagios. You can take the same plugins and put even the Nagios config into Isinga. And within our team, we have also a Isinga core developer this project. So it has advantages forward, and he can implement it. For getting SNMP data from the devices and generating graphs, we use a JackMK in combination with a PNP for Nagios. I've seen PNP for Nagios also on some slides today. So we had a big problem of SNMP load on our network devices. We use Catalyst 6509 in our bigger POPs, and we have different tools accessing it via SNMP. And this JackMK tool optimizes the access rate of SNMP, so it makes it, instead of a GET request for everything it wants to know, it makes one SNMP bulk walk and then afterwards interprets which information it needs and which not. I've made a detailed presentation just about that. It's 20 or 30 minutes. You can have a video stream on of the last RIPE meeting, and you can look at this. It was the focus there was the Vienna Internet Exchange, but I said it's the same for ACOnet and Vienna Internet Exchange. We do not have outsourced anything except what I mentioned with the local stuff on the ACOnet POPs, but everything scheduled is done in Vienna, and we also have an emergency telephone number that everyone, this number is public, everyone can call it and leave a message out of office hours, and this machine then tries to reach one of our network engineers, and answering to that request is, if you want you can, but you are not forced to do it. But normally it works very well. Some of the guys or anyone has always time and answers the calls, and we have a very low number of alarms, so it's about 5 or less than 5 a year. There are some differences of entities connected to an NRAN. So ACOnet is not providing access to schools, for example. So our customers are universities, ministries, and research institutes and kind of this. It's about 120. And then we have a group of dormitories, so student dormitories which are also connected to ACOnet. It's about 150, so around 300 entities connected to the NRAN. Do not offer any SLAs, but like Christina, we have built our network as resilient as possible to avoid having to have some. And we have had a look about on different ticketing systems, but then decided to throw them away and keep our standard mailing list for communication as internal and external communication. So if you send a mail at NOC@ACO.net, it ends up in a simple mailman mailing list. This is a photo of all of us. It's not only NOC, it's all people working for ACOnet and the Vienna Internet Exchange together. So you see, this is these are 9 people, 9 or 10, 10 people. Providing all services we have, and I've made a little bit of an overview who does what. So many people do many things at the same time, and therefore it's rather easy to solve problems together, since except 2 of them, all of us do sit in the same room, and we have found a very nice possibility to for our inter-team communication, which is we prefer to have a lunch together, and therefore it's very easy to discuss things that are going on happened the last day or are planned for the next day and so on. So this is the way we prefer to do it. Unfortunately, we have no scribe during lunch, so there are no official minutes, but normally this works quite well. For documentation, we have more tools. One of them is a professional tool for cabling. It's kind of a cooperation of the NOC team and the facility team of Vienna University, who do all the cabling of the Vienna University itself. So they have installed these tools and we use it together. Then we use kind of a wiki implementation. It's a wiki system the Vienna University Computer Center uses, and we also use it as a synergy effect. And then we have made an homegrown database for ACOnet and Wix. interestingly, these are two different databases if they have grown at different times. They are very similar and they have almost the same feature sets. So if we configure or we want to configure something new, it first gets documented in the database, and then we have some synchronization scripts that generate the configuration lines we need, and we then manually pass it into the devices. And also there's a cron job running every 24 hours that checks whether the documentation in the database still matches the configuration on the network devices. So we see either if we just have quickly configured something on the devices and never documented it, it pops up on the next morning, or the other way around. Some of the documentation might be wrong or different, so these things appear during the next night. Okay, that's it from me. Any questions?
Did you start off without Jinga, or did you have Nagios installed first of all? Start off with a fresh install of Jinga or the monitoring thing, or did you have to
ask about the migration? Yeah. We migrated from one moment to the other when we just loaded the configuration file of our Nagios implementation into Jinga, and it worked. And from then on, we just adopted it. What? Yes. Yeah. We recently also, if the archives have been moved to the new machine, and it was possible, yes. We had problems with the statistics. As I mentioned, we use now PNP for Nagios for generating statistics, and we have been using Cacti in the past. And we thought about migrating the statistics as well, but then decided to just start from new. And we had about half a year of parallel graphing with the old system and the new system. So on the new system, we have now graphs from last June on, and we decided to make snapshots from the old graphs and just archive them. So if you want to see in the past, before last June, we have to look on the archives of the old system, and on the new system, we have at least now 8.
Okay, no more questions?
I might miss, but you have on-duty engineers, so you have shifts, or?
We have committed personnel on site from 8 in the morning to 5 in the evening, but there are no shifts. So out of these hours, you have to call the emergency number. So as Yves mentioned it, you have 1,000 something services on your Singer, 1,200. This has been a problem with Nagios, but it works fine now with Singer, just if you run into some performance problems.
So if the customer calls emergency number, who's answering then? I mean, the emergency number is 24 hours per day?
If someone, whoever, calls the emergency number and nobody lifts the phone, he ends up at the answering machine. If this person lists a message on this machine, the machine tries to call the NOC personnel. Then we can hear the message and call back.
Where does this machine call then? For which phone numbers?
Yeah. Yes, the mobile phone of the network engineers. So there's a defined order of numbers to call, and if the last one also not answered the phone, it waits for 15 or 30 minutes and then starts again with the first one.
My initial question would have been, so you said you have never run into any problems with this sort of with this type of setup. So I remember having had service failures within our network, where we are very happy to have this engineer on duty to prevent further service failures later on. Let's say we were redundant, but we were happy to be able to repair it in time. So,
maybe this is now related to the fact that we are a member of Vienna University staff. So the computer center itself has about 200 people. And normally one of these people is recognizing the problem, and we get alarmed by them. So if any one of the 200 sees a problem, is online, sees that something is wrong, we get also, of course, directly alerted. But it really happens.
So one last comment from me about that, because we really had the requirement of offering 24 hours, 7 days service or on duty service monitoring from, let's say, from the side of our customers. So yeah, it was not only our own homegrown idea. So yeah.
We also thought about that. What do we do if the customers ask us about that? And there was, I guess it was the TF-NOC meeting in Zurich when Henk Nussbacher presented how they made it at IUCC, because they have outsourced this watchdog watching on the monitoring screen and just calling if they recognize a problem. So that would be a step we would make, I guess, because as I mentioned, we have all of the ACOnet infrastructure from Telekom Austria rented. So it would be, I guess, very easy to also give them a monitoring screen so that the issue